Hey everyone! Today, we are diving into the cosmos to explore the closest star systems to our Sun. It is easy to forget that our night sky is full of these massive balls of burning plasma, many of them with their own planetary systems and untold cosmic wonders. We are going to take a much closer look at our galactic neighborhood today and investigate just what these stars are like. We will compare each star to our Sun in terms of type, mass, radius, luminosity, temperature, and distance to see how our own star stacks up against its neighbors. Is our Sun a cosmic oddball or totally normal? Let's find out. Get ready to blast off, because we are going on an adventure to the 10 closest star systems to our Sun. Buckle up. Our first stop brings us to the Alpha Centauri system, the closest star system to our own. But here's the thing, it is not just one star, it is three. We have got Alpha Centauri A, Alpha Centauri B, and then the real standout, Proxima Centauri. Proxima Centauri is a red dwarf star, and it holds the title of the closest individual star to our Sun. It is a cool 4.24 light-years away, which sounds close, but it is still trillions and trillions of miles. It orbits a pair of binary stars, Alpha Centauri A and B. Now let us compare Proxima Centauri to our Sun. In terms of mass, it is quite a bit smaller, only about 12% the mass of our Sun. Similarly, its radius is only 14% of our Sun. It is also much cooler, with a surface temperature of around 3042 Kelvin, compared to the Sun's scorching 5778 Kelvin. Basically, Proxima Centauri is much smaller, cooler, and dimmer than our Sun. The Alpha Centauri system has two other stars, Alpha Centauri A and Alpha Centauri B, which orbit each other in a binary star system. Alpha Centauri A is very similar to the Sun, but slightly larger, slightly hotter, and more luminous. Its smaller companion, Alpha Centauri B, is smaller, cooler, and less luminous than our Sun. Scientists have even discovered a few exoplanets orbiting Proxima Centauri, though whether any of them could support life is still a big question mark. Next up on our cosmic road trip is Barnard's star, a red dwarf star hanging out about 5.96 light-years away from Earth. Barnard's star is known for being a bit of a speed demon. It is actually the fastest moving star in our night sky, zipping across the celestial sphere at a rate of 10.3 arc-seconds per year. But let's get down to the nitty-gritty. How does Barnard's star compare to our own Sun? Well, in terms of size, it is a lot smaller, with a radius of about 0.2 times that of the Sun. It is also much cooler, with a surface temperature of around 3134 Kelvin, giving it that characteristic red dwarf glow. Because of its small size and cool temperature, Barnard's star is actually much dimmer than our Sun. In fact, it only emits about 0.3% of the Sun's luminosity. Despite its small size, Barnard's star has still been a popular target for astronomers. There has been a lot of back and forth about whether or not it hosts any planets, with some studies suggesting the presence of a gas giant, but nothing has been confirmed just yet. Our next destination takes us to a slightly different kind of star system, Luhman 16. This system is home to not one, but two brown dwarfs. Brown dwarfs are kind of like the awkward middle child between stars and planets. They are bigger than planets, but not quite big enough to sustain nuclear fusion in their cores like true stars. Thus, they are not true stars. The two brown dwarfs in Luhman 16 are known as Luhman 16A and Luhman 16b, and they orbit each other at a distance of about 3 times the distance between the Earth and the Sun. They are located about 6.5 light-years away from us. Luhman 16A has a surface temperature of around 1350 Kelvin, while Luhman 16b is even cooler, at around 1250 Kelvin. Studying brown dwarfs like those in Luhman 16 can help us better understand the processes of star formation and the boundary between stars and planets. WISE, Z0855, Z0714, the sub-brown dwarf Enigma. Hold on to your hats, because we are about to venture into the realm of the truly bizarre with WISE, Z0855, Z0714. This enigmatic object is classified as a sub-brown dwarf, which is even cooler and less massive than a regular brown dwarf. Thus, it is not true stars either. WISE 0855-0744 is located about 7.5 light-years away from us. It is estimated to have a mass between 3 and 10 times the mass of Jupiter, putting it right on the boundary between a planet and a brown dwarf. It has a surface temperature estimated to be between 225 and 260 Kelvin, which is colder than a winter day in Antarctica. Because WISE 08550714 is so faint and emits so little light, it was only discovered in 2014 using data from the Wide Field Infrared Survey Explorer, or WISE, space telescope. Wolf 359, the faint red neighbor. Next on our cosmic journey, we are stopping by Wolf 359, a red dwarf star located about 7.9 light-years away from Earth. If you do not count Luhman 16 and WISE 0855-0714 as true star systems, then Wolf 359 would be the third closest star system to our own. Wolf 359 is also where the infamous battle between the Borg and the Federation took place, in the science fiction TV show Star Trek: The Next Generation. It is incredibly faint, with a visual magnitude of only 13.54. That means you would need a pretty powerful telescope to even spot it from your backyard. It is much smaller and cooler than our Sun, with a radius of about 0.16 times that of the Sun, and a surface temperature of around 2,800 Kelvin. One of the interesting things about Wolf 359 is that it is known to be a flare star. These flares are thought to be caused by magnetic activity on the star's surface, and they can release enormous amounts of energy. While Wolf 359 might not be the most visually impressive star in the sky, it is a reminder that even the faintest objects can have their own unique stories to tell. Lalande 21185, the high proper motion star. Get ready to meet Lalande 21185, a red dwarf star located about 8.31 light-years away from Earth. Lalande 21185 is known for being a bit of a mover and shaker in the cosmic sense. It has a high proper motion, which means it appears to move across the sky at a relatively fast rate compared to other stars. Lalande 21185 is, you guessed it, a red dwarf star, which means it is smaller, cooler, and dimmer than our Sun. It has a radius of about 0.39 times that of the Sun, and a surface temperature of around 3,500 Kelvin. More recently, as of mid-2024, Lalande 21185 has made headlines again with the discovery of 2 exoplanets orbiting it. These planets, designated Lalande 21185b and c, are both super-Earths, meaning they are larger than Earth but smaller than Neptune. Sirius System, a tale of 2 stars. Our next stop takes us to the Sirius star system, home to the brightest star in our night sky, Sirius A, and its intriguing companion, Sirius B. Located a mere 8.6 light-years away, Sirius A is a true celestial showstopper, easily visible to the naked eye even in light-polluted cities. It is a main-sequence star, just like our Sun, but it is much hotter, larger, and more massive, giving it a brilliant white-blue hue. But Sirius A is not alone in this cosmic dance. It has a much fainter companion, Sirius B, which orbits it at a distance of about 20 times the distance between the Earth and the Sun. Sirius B is a white dwarf, the remnant core of a star that has exhausted its nuclear fuel. It is just as massive as our Sun, yet it is much smaller and is about the size of our Earth. The contrasting nature of these 2 stars makes the Sirius system a fascinating case study in stellar evolution. Let's take a closer look at another fascinating system, Gliese 65. Also known as Luyten's star, this binary star system is situated approximately 8.73 light-years away from the Sun, making it one of the closer neighbors in our galactic neighborhood. Gliese 65 consists of 2 red dwarf stars, designated as Gliese 65a and Gliese 65b. These stars are much smaller and cooler than our Sun, with surface temperatures around 2,700 degrees Kelvin. Despite their modest size and faint luminosity, red dwarfs like those in the Gliese 65 system are among the most common types of stars in the Milky Way galaxy. Currently, there are no confirmed planets orbiting Gliese 65, but the search continues as astronomers use advanced techniques to detect any potential exoplanets that might be hidden within this binary system. Gliese 65 holds particular significance in astronomical studies due to its proximity and the characteristics of its constituent stars. Observing and analyzing binary systems like Gliese 65 helps astronomers understand stellar formation, evolution, and the dynamics of multiple star systems. Furthermore, Studying such nearby systems provides valuable data that can be applied to more distant and complex stellar environments. In conclusion, the Gliese 65 binary star system is a reminder of the intricate and diverse nature of our galaxy. Ross 154, the active flare star. Hold on tight as we journey to Ross 154, a red dwarf star located about 9.69 light-years away from Earth. Despite it being smaller, cooler, and dimmer than our Sun, Ross 154 is known for being a bit of a hothead, literally. It is classified as a flare star, which means it experiences sudden, unpredictable increases in brightness. These flares are thought to be caused by magnetic activity on the star's surface, releasing enormous amounts of energy in the form of intense bursts of radiation. Red dwarf stars like Ross 154 tend to spin much faster than stars like our Sun, which can amplify their magnetic fields and lead to more frequent and intense flares. While these flares make Ross 154 a fascinating object to study, they also pose a challenge for the potential habitability of any planets orbiting it. Ross 248, a future traveler. Next, our cosmic adventure brings us to Ross 248, a red dwarf star located about 10.32 light-years away from Earth. Ross 248 might seem like a quiet, unassuming star, but it has a remarkable future ahead of it. In about 33,000 years, it will actually become the closest star to our Sun, taking over the title currently held by Proxima Centauri. Ross 248 will come within about 3.05 light-years of our Sun before moving on, eventually relinquishing its title as the closest star. It is a typical red dwarf, much smaller, dimmer, and cooler than our Sun. It has a radius of about 0.2 times that of the Sun, and a surface temperature of around 3,000 Kelvin. As of mid-2024, while no planets have been confirmed around Ross 248 yet, astronomers are still searching for potential companions. Epsilon Eridani is located just 10.5 light-years away from our Sun. Epsilon Eridani is also the location of the Babylon 5 space station, from the Babylon 5 sci-fi TV series. This star is slightly smaller and cooler than our Sun. It is also less luminous. It has a fascinating planetary system that includes at least one confirmed planet. Epsilon Eridani has been a subject of interest for astronomers due to its similarities to our own solar system and its potential for hosting life. This star's planetary system features a debris disk, much like our Kuiper belt, hinting at the dynamic processes shaping its celestial companions. Join us as we explore the wonders of Epsilon Eridani and its intriguing celestial companions. From the potential for life on its planets to the mysteries hidden within its debris disk, this star system offers a captivating glimpse into a world not so different from our own. As we continue our journey through the cosmos, Epsilon Eridani stands as a reminder of the endless possibilities that await us among the stars. Lacaille 9352 is located 10.74 light-years away from us. As before, if you do not count Luhman 16 and WISE 0855-0714 as true star systems, then Lacaille 9352 would be the 10th closest star system to our solar system. This red dwarf star is much smaller, dimmer, and cooler than our Sun, but it has been the subject of much interest due to its proximity. Despite its faintness, Lacaille 9352 is a fascinating object for astronomers studying the characteristics and behaviors of red dwarf stars. Being a red dwarf, Lacaille 9352 has a relatively low luminosity, making it invisible to the naked eye from Earth. However, its proximity allows astronomers to study its properties in great detail. Red dwarfs like Lacaille 9352 are known for their long lifespans, often burning for billions of years longer than stars like our Sun. One of the most captivating aspects of Lacaille 9352 is its potential to host exoplanets. While no planets have been confirmed around Lacaille 9352 as of yet, its stable environment and long lifespan make it a prime candidate for future discoveries. Studies of its radial velocity have shown intriguing signals that suggest the presence of planetary companions, though more data is needed to confirm their existence. Moreover, Lacaille 9352's relatively calm nature compared to other red dwarfs makes it an excellent subject for understanding the magnetic activities and flare behaviors of these stars. By observing Lacaille 9352, scientists can gain insights into the potential habitability of planets orbiting red dwarfs. As we delve deeper into the mysteries of Lacaille 9352, we are reminded of the vast diversity and complexity of stars within our galactic neighborhood. This red dwarf star stands as a beacon of curiosity, inviting us to unlock the secrets of the universe, one stellar neighbor at a time. So many stars, so little time. In conclusion, the universe is vast and full of wonders. Well, there you have it, folks. A whirlwind tour of the 10 closest star systems to our sun. Well, 12, if you were to count Luhman 16 and WISE 08550744 as star systems. It is incredible to think that these celestial objects, some shining brightly, others barely a flicker in the vastness of space, are our nearest cosmic neighbors. As we have explored these star systems, from the triple star system of Alpha Centauri to the small dim star of Gliese 9352, we have encountered a diverse cast of characters: red dwarfs, brown dwarfs, energetic flare stars, and even a white dwarf. Overall, most of these nearby stars are red dwarfs, which are smaller, cooler, and less luminous than the sun. So, yeah, our sun is a little bit of a cosmic oddball in our local neighborhood of stars. Each star has its own unique story to tell, shaped by the fundamental laws of physics and the grand dance of cosmic evolution. What is even more mind-blowing is that these star systems are just a tiny fraction of the billions upon billions of stars that make up our Milky Way galaxy. And beyond our galaxy, countless more galaxies stretching out into the vast expanse of the universe, each teeming with its own collection of stars and planetary systems. Thank you for joining us on this journey through the stars.
Thank you for watching. Hope you found this video informative and entertaining. Please subscribe, like, share, and comment. We do like to know and hear your feedback. And if you have the means, please consider supporting us on Patreon, where you can get early access to our videos, and where we post bonus material. Till next time, this is Geeky Tidbits saying cheers and have a good day.